So this first example takes into account electric car batteries. And we want to establish that the thermal conductivity of a certain kind of cement brick differs from 0.34, the value claimed. We'll test on a basis of a sample size of 35 and a 0.05 level of significance. So this is our alpha value, also called the level of significance. From the information gathered in similar studies, we can expect the variability of such determinations given by, so we have the standard deviation of the population as 0.01. And we're also given the mean here of 0.343. So how do we go about this? The first thing we need to do is define our hypothesis, or our hypotheses. So we have the null hypothesis here, that our mean is equal to 0.34. Our alternative hypothesis is the mean is not equal to 0.34. So in this situation, this is the alternative hypothesis. So it's in this framework. So we would use, this is the criteria that we use to reject the null hypothesis. So we would only concentrate on this row here for our test. Okay, so we calculate Z, and we have the mean here, and then we have the value that it's supposed to be, or the intended value. So we subtract those two and divide that by the standard error, and we get a value of 1.77. Okay, so once we have that, we keep that around, that value of 1.77, and we use that for the criteria in the test. So the criteria for the test is Z is less than this negative Z alpha divided by 2. So in our case, alpha is 0.05, so we need to divide that by 2, and we would get Z 0.025. So that is our Z value. Okay. So we would just complete this criteria. So 1.77 is less than negative 1.96. So that's no, that's not true. This statement is not true, right? But we also need to check the other side. We need to check this other 1.77 is greater than 1.96, and that's also false. So neither one of these are true. So we do not reject the null hypothesis. So we would say something like this does not satisfy the test. We fail to reject the null hypothesis. So the difference between our measured value of 0.343 and the claimed value of 0.34 can be attributed to chance. So the difference between those could just be based on the sample that we chose out of the population. So we cannot say that these are different, basically. So we conclude that the mean is equal to 0.34. That's our null hypothesis. The mean conductivity is 0.34. Okay, so we calculated Z. We looked up these values in the table. So we can look up these values in the table, or we know that this value, we've seen this before, of Z 0.025 is equal to 1.96. And then we check this test if we want to reject the null hypothesis. And it doesn't satisfy the check, so we don't reject the null hypothesis. So that would conclude that we go with the null hypothesis. So a lot of times we're looking at the difference between our measured value, or our best value, and the expected value, so between those two. So we want to look at the probability of getting that difference or greater. Okay, so what the difference is between those the values or greater in terms of probability. So here we have this normal curve for the example, and remember that our Z 0.025 was 1.96. So That's what's shown on these values. And what we actually found with our, when we calculated Z, is 1.77. So these two values represent 1.77. So we're looking at the probability beyond those curves. So we have here, it's on both sides here. And the area underneath this curve is actually the probability. So the area underneath these curves. So we need to add those up. So this over here, this area is 0.0384, and over here is 0.0384. So we add those together, and then we get a value of 7.68%. And that's our tail probability, or also known as our p-value. So that is the probability of getting a difference. The difference between these two values is greater or equal to what's actually observed. Okay, so our p-value is 7.68%, and then obviously that is greater than our 5%, our alpha value. So we say that, we commonly will say that this is not statistically significant, or this is not a statistically significant result, saying that our measured value is not different enough from the expected value. Okay? So that's what the p-value is. And that's kind of a hard concept to grasp, but that's okay. We'll get some experience with that. So just a quick mean, or a quick meme. I don't know what p-value is, and at this point I'm too afraid to ask. So just remember that the p-value is actually the area under these tails here is really what we're looking at for a p-value. And then if our p-value is less than our alpha value, we say that it's statistically significant. If the p-value ends up being bigger than our alpha, we say it's not statistically significant. And that was what the result was for our example that we just did.